If you were like us and barely knew how to define a planet, then the term exoplanet would have obviously scared you off a bit. But since there's so much aggressive research being made into celestial travel and things like Elon Musk launching a car into space are happening so often in the news, we figure it's about time we got updated. So stick around to find out everything there is to know about some of the most fascinating exoplanets. Let's kick it off by discussing what actually are exoplanets. It's actually not as complicated as you would imagine. We give the term planet to all the bodies of mass that are in orbit around the sun, and exoplanets are those that don't have a sun and simply orbit other planets. Our solar system doesn't have any exoplanets because we have a sun with a huge gravitational pull that doesn't allow the stars to orbit each other. These huge orbs of rock are really hard to see with the telescope since they are likely to be less illuminated, or they even end up being hidden under the glare of their orbiting stars. We are now sure because of NASA's efforts that thousands of exoplanets have only just been discovered, and the possibility of them containing life keeps us going. Now on to why are we studying them? Right now, the biggest aim that scientists have is to use this new and amazing technology to find terrestrial and habitable planets or even find biological life. As soon as they discover exoplanets that have enough water for oceans, we could be looking at a new era for all of us. Truly, this feels like we are finally entering the start of some science fiction movie, discovering new stars and new species. One of the main reasons scientists are looking for exoplanets with water is that theoretically the hydrogen could be separated from the oxygen and be turned into really powerful rocket fuel for space exploration. So these planets would basically be just a huge gas station for humanity. Its missions are to observe the known galaxies for scientists to be able to answer many important questions. It will help us in understanding how galaxies form and a timeline for how long it has taken. Just think of how many scientific as well as religious questions that could answer. We also know very little about this strange phenomenon known as dark matter. As those few science enthusiasts watching would understand, dark matter is 5 times more in quantity than normal matter. Scientists believe that the telescope will be really important in seeing all these things up close. Just imagine that your children might be studying what you're experiencing now as just common knowledge in the future. Humanity's ongoing hunt for exoplanets is something that the telescope will further beyond our wildest imagination. But with that, we'll also be able to look at our own solar system better. We can now see all the way out to the edges of our own solar system for hints to our own creation. So all in all, this new telescope might end up being as important as Galileo's first invention. Let's talk about how we are able to see exoplanets. Right now, our options are limited if we want to have a close look at far-off exoplanets, but the growth in this industry is moving at an exponential rate. The James Webb Telescope is the most recent breakthrough and has expanded our reach like never before. So what you have to understand is that there has never been an infrared telescope before, and that is why the JWT has everyone so excited and frankly terrified. We're sure we aren't the only ones sitting in an existential crisis as the scientists over at NASA tried explaining how tiny we were in the latest images. The internet erupted with mixed views with everybody confused as to what to feel. Basically, infrared wavelengths are what allows the scientists over at NASA to see the first stars, galaxies, and exoplanets forming since the Big Bang. The reason the telescope is as strong as it is that it sees into space with giant gold mirrors. Why gold, you ask? Seems like a huge waste of money, right? But it's actually because gold is what reflects the infrared radiation. A giant 40-foot or something mirror made of gold was obviously too large for scientists to launch into space, so instead they divided them into a clever hexagonal design made up of 18 tinier mirrors. This would be launched, calibrated by the scientists down on Earth, and would be able to unfold in space. One method for looking for exoplanets is to search for wobbly stars. A star that has planets doesn't circle flawlessly around its middle. From a long way away, this topsy-turvy path the planet takes makes it seem as though it's wobbling. Next up, besides the JWT, what else can be used to see exoplanets? Another exciting development recently in exoplanet research has been the Magellan Telescope. We are working with some of the brightest engineers and scientists at leading research institutions around the globe, said the board chair for the Magellan Telescope, Walter Massey, in a recent interview. For a project this large, we had considerable doubts over it even passing the initial funding phase, but the most recent $205 million investment positions the giant Magellan Telescope to be one of the primaries in another age of very enormous telescopes to be developed. First light is actually expected before the decade's over. 6 of 7 essential mirror fragments have been set up in Tucson, Arizona, and and the third essential mirror section has finished its 2-year cleaning stage and is going through its final testing. The Giant Magellan Telescope is viewed as a state-of-the-art exploration device. It will utilize 7 of the world's biggest mirrors. The 25-meter mirror exhibit comprises 7 8-meter widths that weigh 18 metric tons to deliver the most nitty-gritty pictures at any point taken of the universe, completely overtaking the James Webb Telescope in every single regard. Yet, the Giant Magellan Telescope will take things to the next level. The total light gathering area of 368 square meters will show pictures sharp enough to determine the light shining in a very small space from almost 160 kilometers away. The telescope mount is 39 meters tall, weighs 2,100 tons, and is housed in a 65-meter casing that can make a full turn in around 3 minutes tops. 7 versatile auxiliary mirrors can reshape the 2-millimeter thick surface 2,000 times each second to address the optical masking impact of Earth's air over the largest field of perspective on any telescope. So clearly, humanity is going to have a lot more development made in the coming years, and maybe we'll even get to visit one of these exoplanets in our lifetime. And finally, some of the most interesting exoplanets we've learned about. We've learned of some wacky exoplanets, but what could some of these mean for us? Starting with Kepler 10b, this has to be one of the coolest ones we've come across. Actually, no, not quite. Found in 2011 by the Kepler telescope, it makes liquid drops of iron and silicates. The planet's surface is covered with magma that's hotter than any found on Earth because of the intense radiation from the stars around it. The lava surface reminded a lot of fans of the fictional Star Wars planet Mustafar, actually where the final battle between Obi-Wan Kenobi and Anakin Skywalker took place, and the young Anakin transitioned into Darth Vader after being melted on the lava bed. This just shows how things we imagine to only be fiction could very well prove to be a reality as more and more exoplanets are discovered. Next, rogue planets and OGLE 2016 BLG 1928. Stargazers trust that the Milky Way could be overflowing with enormous orphan exoplanets that have broken away from their orbits and wander through the universe alone, flung through the galaxy, riding out the gravitational pulls of other stars. These planets are extremely difficult to find and had only been theorized about, but scientists used a technique called gravitational microlensing to detect the planet through the disturbances it caused to other solar systems. The idea that a planet could be so detached from any framework and just hurls through space on its own whim is something that really puts things into perspective for us. Wrapping things up with the Diamond Planet, estimated to be almost twice the size of Earth and around 384 quadrillion times more valuable. 55 Cancri is made up of carbon, graphite, iron, and highly compressed diamond. The idea of this entire planet being composed of such valuable metals and minerals has seemed too good to be true for scientists, but after much research, it proves to be the only explanation for why the planet is so dense. This is just one of the many discoveries we've made in recent years and just gets us wondering, how much more potential does the human race still have to unlock that'll be made possible pretty soon if we are able to travel to all these astonishing exoplanets? And will we ever get there? That's a wrap for this video, and thank you for watching. What do you think of scientists' studies of exoplanets, and which one would you like to travel to first? Let us know in the comments below. Make sure to give this video a thumbs up and subscribe to our channel for more videos like this. See you in the next one.